Yeah. Good afternoon, guys. Today, so I uploaded this notebook on week 8. Uh, so today we will teach our model to reply what we want to hear, not that model was trained on. So, and we will try to build learnable prompts and low-rank adapters. Two approaches. Let's see. I don't know. So do you have any questions about homework? Yes.
Yeah, I can ask you after if it's too specific, but when I was working on the homework, which I think I just closed out of, I wasn't able to
Bird
get
or
very
GPT?
Bert.
Yes. I uploaded I made the announcement.
Yeah, I saw that, but still like my accuracy couldn't really get much above like 83%.
Okay, let's see. I can, oh yeah, I believe I have the notebook. Let's see. Um, so this was week 6. Um, so let's see. I believe it was, yeah, train the model. So we import the model. Um, um, and we use classification because you can use it's the other import causal model, then it will output logits for all the words. If you use classification import, then it will return only the logits of CLS token for bird, or it will return the last token for GPT model embeddings. So, but it will return two numbers if it's binary classification, or whatever number of classes you will indicate. So next thing, yeah, we pre-process the data. And this is the, I don't know what is, do you have any questions about data pre-processing? But
So
I
we
believe
should
it's,
train on the validation set.
no, we should train on the train set.
Okay.
um, oh, wait a second. I'm using validation loader. Let's see. Um, okay, it looks like this is my mistake. Um, I, or maybe I have another code below because I tried different approaches. Maybe What is, oh, wait a second. No. That was code for accuracy. That's why there was validation. Sorry. Let's see. For training, so we use if we use mixed precision, yeah, here I'm using training loader. So, okay, I'm not completely crazy to train on validation set. And actually, my model converged just in 30% of the first epoch. I don't know why your model didn't converge. So we read data, we get the logits from the model, we apply cross entropy loss on logits and labels, and then we zero gradients and do backwards to calculate gradients and provide optimizer step to update the parameters. And that's it.
Yeah.
So I interrupted because it converged before the first epoch actually finished. And then on the training, okay, I don't see the accuracy, but it reached the accuracy.
Okay.
So, well, if you have any other questions, we can maybe meet
Yeah.
on Zoom.
Yeah.
Okay, so let's open the current notebook on Kaggle. It's pretty cool because yeah, it provides so many hours per week that it's more than enough to work on homework. So practice. And I realize now that I actually uploaded the completed notebook. So my idea was that we will type, but we will just run it because I didn't have time to remove my code and prepare the notebook. Okay, where is it? New notebook. Open, link, open, okay. Okay, so now I will upload the model in 4-bit precision. So it will take a little bit time. Oh, okay. To upload, to quantize the model. So the it's called Hugging Face. They use another library for weights quantization, which is called bits and bytes. So that's why if we want to apply quantization, we should also import this library. Also, I added this flag that doesn't print all the packages installed, this information. Oh, actually, this is running okay. So we will use a small model. And also we will quantize the weights. So it will take less space on GPU. And we set parameters requires grad false because we don't want to change the model itself. And there is the warning that says that we are using old version of Llama tokenizer because I'm using here Llama 1, I believe, maybe 2. Um, and if for some reason you want to use new tokenizer for current Llama model, you should use flag legacy is false. By default, it's true. And here it quantizes, so it saves the weights of the model in 4-bit precision. And finally, it uploads something. So actually, it downloads the where is it? This quantization. It downloads it quantizes only, as I mentioned last time, the weights of the linear layer except bias. Okay. And now let's provide the prompt. Tomorrow is the spring break and see what is the output of this prompt. It's the spring break for kids. I'm so excited. Okay, this is the previous phrase. I changed this to the spring break. So we don't need this cell. It just illustrates how we can get the logits from the model, just output.logits, and you can, because your model predicts kind of on one step ahead, so we take the predictions shifted to the left from the model and compare with true labels that will begin from the first index. And we can calculate the loss between the phrase that we want to see and the logits that model returns. So the first approach will be to learn several, I believe 16 tokens, such that if we use these tokens before this prompt, today is the spring break, the model will continue this phrase, I will miss the school, instead of I'm so excited. So here is, I didn't want to give this as a homework. In the homework, I will ask you to use the built-in library, PEFT library. And here's the implementation just from scratch. How can we add these learnable prompts? So we have word embeddings from our model, but we will create, bless you, additional embeddings for input num prompts for this number of additional tokens, that embeddings for tokens that we will train. So we create the embedding layer of this size, the number of added prompts, and the size of the embeddings will be the same as the size of the embeddings of our model. And what we're doing next, we create these learnable prompts and concatenate with embeddings from our real prompt. You remember the idea that we have a prompt and we add some embeddings in front of this prompt. So here I concatenate the learnable prompts with real embeddings of the prompt, and return this as the output of this module. So this module will just add the learnable prompt to our real prompt. And then we change the embedding tokens of our model to this embedding with additional learnable prompts. Okay, what's the number of prompts is not defined. I didn't run this cell. Okay. And this is the phrase that we want to see after the training. So what we're doing here, we take the outputs from our model and how to explain? So we have the prompt. Tomorrow is the spring break. So we take the tokens that model generated after this prompt. So from index the length of the prompt and compare with our phrase that we want to see. I will miss the school, and use this in our loss function. So we force the logits from our model to get the highest probabilities for the desired output of the model. And let's see. So yeah, we can train it. So in this case, we don't change the weights of the model at all. We just created fake additional tokens, which doesn't have any sense. Those just some numbers. But if we add these tokens to the input of our prompt, let's see the output. Then if we use as the prompt tomorrow is the spring break, and just run our GPT model on this phrase, it will continue as desired. And also it adds more what's called emphasis or okay. So this is the first approach for trainable prompt engineering. So the next approach will be to actually change the model architecture, to add low rank adapters. As a project, for this homework, I'm thinking to give you to code this by hands, like I did this for the learnable prompt. But we will use now the implemented low rank adapters. So it was all homework in Yandex School to write and by hand and use the built-in library, but I think it's too much work for one homework. So let's import PEFT library. And PEFT library has its own configuration. And in this configuration, okay, we don't need this line as well, because here I just wanted to show that the model has parameters config, tokenizer, but now this lower config is a different thing. In lower config, we will indicate what is the rank of our adapters, what is which layers we want to change, to extend. And here is an example of this low rank config. Which task? It could be classification for if we could use maybe I will just upload this notebook, another notebook. We could use learnable prompts also for classification task to force our model to get better classification of. So here you can use classification. In this case, we're using the causal mode when we just predict next token. The size of our matrices, the parameter is just a constant in front normal distribution. When we initialize our weights, we can multiply by different scale. Drop out for added or for extended parts of our layers, because we won't use drop out in the frozen layers of our model. And then you can also indicate which layers you want to extend. For example, just the transformer layers. By default, it will extend all linear layers. So let's create now extended model. So you pass PEFT config and model to get PEFT model. And if you look at this model, you will notice these adapters, LoRa A, LoRa B. And do you remember why do we have two adapters, and why the shape here is 4000 by 8? Do you remember the oh, I don't have the do you remember the image? So we have two matrices, and they're called A and B. And why the size of these matrices is 4000 by 8 and 8 by 4000. It's just because we indicated the parameter in config, the parameter of rank 8. If you would indicate 4, it would be by 4, and so on. Yep. Okay. So our model uses 4-bit precision, but the parameters will be in I believe 32-bit precision, or 16, actually. We can check it. I believe in 16. So you remember okay, let's so you remember we used this method auto cast for precision. So by default, it casts all the matrix multiplications in 16-bit precision, and the activation function operations and linear norm in 32-bit precision, because so if we have the model in 4-bit precision, for backward propagation, it will dequantize back from 4 bits to 16 bits and use dequantized weights for matrix operations. In forward mode, it depends on the implementation. In this PEFT library implementation, it will cast the weights in forward mode in 4 bits. In other implementations, it can cast everything to 16 bits in forward, but in backward, it will cast to the higher precision. So our input prompt is tomorrow is the spring break, and the phrase that we want to see, I will miss this, or maybe you don't want to see this phrase, but we will force our model to provide this context. So we apply tokenizer, and for labels, we apply mask, and for labels corresponding to our input prompt, we will assign value -100, which cross entropy loss understands as ignore. So this is something new that we didn't use before. So it when it calculates the cross entropy loss, it won't calculate this for the first input tokens. Or actually, okay, in my code below, then I did extra job because I kind of cut the input tokens in my loss function, but I could use without actually cutting because we have, but because I just wrote this right before class, I have forgotten about this, and I just cut. So in the code below, yeah, we don't need to cut the input prompt because this -100 actually will take care of the ignoring this input prompt. So what we're doing next? Here I add, so I concatenate the input prompt with just dummy tokens to get the input shape to the model the same as the output shape. Like my input phrase is longer, or my output phrase is longer, so I will just add extra tokens here to get the same shape. Because when we apply model, it will generate embeddings, and the number of embeddings will be the same as the number of tokens. So if I want to get this phrase as the output, so my model should generate this number of embeddings. So the input string also should be of the same length. Okay. Okay, it will say input int is not defined. Out. So I create convert these phrases into tokens, indices in our dictionary. Then pass to device. Why does it say that name input IDs is not defined? Oh, I see. This should be in tokens indices because it's a dictionary which contains indices and also attention mask. But I will need to rerun again because I added dummy tokens. I should create again input output tokens. Oh, wait a second. It's still in token. Oh, token. Oh my gosh. Okay, so we created uh, this padded sequence of input tokens and attention mask for this input. Now we can calculate the output from our PEFT model from this input. Okay, what's wrong here? Uh, hmm. What is that? Oh, this is the search. Wait a second. Hmm. It's that. Input sequence must be longer than the number of prompts. It should first. So we have input tokens IDX, which is this tensor with attention mask. So what's the problem? Input sequence must be longer than. I didn't see this error before. Okay. Um, I'm confused. What is the problem? In token IDX, it contains the tensor with indices and attention mask, and why our model doesn't work. Mhm. I don't understand. Um, okay, what if I open my notebook? Just the same. Something weird, because I don't see any problem. Let's see. Oh, I think because we changed the embeddings of our model, I should rerun the model uploading here. Okay, and then it should work because the embeddings layers, I believe, we changed. And if we re-upload now the model, it will work. I hope so. Okay, it looks like, yeah, it worked. So as okay, great. And as I said, here I kind of concatenated the input prompts but you don't need to do this. So we can train it. So torch. Oh, do you remember how to call optimizer torch optim? Oh, yes. And yeah, now it's train, and we have 1 minute left. So, well, but it will converge in about also 50 epochs. Just I want to show you the output from the model for this prompt. Um, and there are many other, not many, but two more LoRa libraries. One is called QLoRa, quantized LoRa, that doesn't cast back the uh, coefficients to the 16-bit precision, but works on the quantized model. And also another model that uses quantization of activation layers as well. Okay, it almost converged. And because this will be your homework after the break, I hope I will upload this during this weekend. Okay, it's almost converged. Yes, and this is the output from the model on this prompt. Okay. Okay, so we fine-tuned this model. Okay, have a nice break. I hope you will miss the school. And, yes, see you.